Here's the spreadsheet we developed for question 4 of Unit 12. We had the choice between buying 3 different houses. One cost $50,000, another $100,000, and a third $200,000. In each case, we have just $50,000, so anything extra will need to be borrowed from a bank. For example, if we buy the $200,000 house, we'll spend $50,000 of our own money and borrow $150,000. The money we borrow is borrowed at an APR of 7%. We worked out the equivalent annual rate that a 7% APR is equivalent to. That's 7.23% approximately. And we applied that to the amount that we borrowed to find out how much we would owe after 1 year. Here's the cost of the house. Here's what we borrowed. Here's what we owe at the end of the year. When we sell the house, in question 4, we assumed that we would sell it for 10% more than we bought it. So here, if we bought it for $200,000, we'd sell it for 10% more, $220,000. The amount we get to keep at the end of the year is the sale price minus what we owe the bank, and that's this amount here. The results are fairly clear just in this column. The best deal for us is the $200,000 house, and the worst deal is the $50,000 house. But we can put this into familiar investment terms by asking what return we earned on our money. What percentage did it increase over the year? In each case, we started with $50,000. So what did we increase to go from $50,000 to $55,000? We apply a standard percentage formula and find that we increased our money 10%. Or in this case, 12.77%. And finally, in this case, 18.31%. This shows the power of leveraging. In this case, we borrow money at 7.3%, but we earn money on our investment at 10%. The more we borrow, the more we earn. We're earning money not just on our $50,000 investment, but also on the money that we borrow from the bank. And therefore, the more we borrow, the better. On the other hand, things are not always so nice. In question 5, we ask, what if in exactly the same circumstances, housing prices rise 4% a year rather than 10%? The only column that changes here is this one, which shows the house price at the end of the year. It won't be 10% more, but rather 4% more. Dragging this down to apply it to the other cases as well, we find now that results are reversed. If we buy the $50,000 house, it goes up 4% and we earn 4% on our money. But if we buy the more expensive houses, we earn a lower return on our money. In fact, the most expensive house turns out to be an investment in which we lose 5.69%. Here, leverage works the other way around. The more money we borrow, the more we lose because we're paying more for the money, 7.23%, than we're earning on it, 4%. Leverage increases the returns in either direction. If we can make a good investment, one that makes more than we're paying for our money, the more we borrow, the better. On the other hand, if we make a poor investment, one that costs us more than we're paying for the money, the more we borrow, the worse off we are.